Hello. As the board says behind me, my name is Edward Chudleigh, and I have been here to do a talk before, so if I repeat anything, I apologise, but I've tried to make this as new as possible. And I'm going to talk a little bit about sort of what's happened in this weird year and a little bit before the year got started. So obviously, we've had this pandemic, or still having this pandemic, and but it's great to see real people, not on Zoom, not on digital devices, so you're actually here. So it's my pleasure to come and give you this talk. It's going to be a bit about art technology, engineering, what's the difference, and what's the future. I'm going to make it as interactive as possible. So if you do see something you don't understand, just put your hand up and just ask. It's absolutely fine. I'll stop the presentation, cry, and try and work out how to answer it. I'm sure it'll be fine. So, moving swiftly on, hopefully it's going to work. Why am I here? And where did I come from? It's not a stupid question. You can already guess that I came from my mother. But actually, before Millfield, I came from a place called Salisbury, which isn't very far away. Probably some of you know where it is. Big, tall, pointed cathedral and Stonehenge, the bunch of rocks that everyone goes and gets people to look at when they come from abroad. And really, I came here because my dad said, you've got to go and see this school. It's amazing, and I think you'll really like it. So he taught me along here. Had a look around, I was like, it's more like a university campus, it's amazing. And he's like, you like it? Yeah. Right, you've got to get a scholarship. I'm not paying. And so I worked quite hard, and I was very fortunate, and I came here with a scholarship, and I was here for a while, and just found it a fantastic place and area to basically study and sort of broaden my horizons of the things that I really enjoyed. And I'm sure a lot of you guys feel that with the fantastic facilities we see around us today. It's changed somewhat since I've been here. This was never here. And when I was here, the Maya Theatre was being built. So it shows how old I am. So moving on, pre-Millfield, Millfield and post-Millfield. What you enjoy and what you're good at, it's not always the same. Sketching out the basics. And what I mean by that is, I was always intrigued by engineering, and I knew I needed to be good at maths for that and good at physics, and basically all the subjects, all the things I wanted to do, I was not very good at. I was more sort of art-based, more creative, building things with my hands and that sort of thing. So I was a little bit lost as to how I was going to get there, how I was going to understand these sort of subjects. And really, so this place put a lot of those building blocks together for me. And I say sketching out the basics because I always use one of these. And from an artistic background, I was always learned to put things in a sketchbook and work out the building blocks of whatever it was I was trying to figure out. And so from there, really, I've discovered all of that at Millfield, but with the design and technology and the art, I could see there's sort of intrinsic links between the whole lot. And really what you do in creating in your head in these things and then putting it onto paper, you can do with maths, physics, and reverse as well, and we'll come on to that in a bit. So university, the degree, flying. I fly for a job, I do engineering, I do art, basically. Essentially, my first course, after sort of leaving Millfield, university-wise, was to study aeronautical and astronautical engineering. And this sounded amazing and fancy, and I thought, right, we're going to build rockets, we're going to go to the moon, we're going to design all these amazing machines. But actually, it was books and books and books of maths and physics. But that's not to say it's a dull subject at all, because it was very interesting. But my brain's really not that kind of way tuned to that kind of stuff. So I had to do it in a sort of pictorial way. But the great thing about it was I joined the University Air Squadron when I was there and learnt to fly airplanes and really sort of had a good understanding of how disciplines and things fitted in with machines and how they work. Then I went on to the proper degree, which is what I call it, which was industrial design and engineering, which was at Brunel University. And really there, I sort of got to grips with my love. It was an amazing course. It went from life drawing to programming robots, and building the most amazing machines. So it crossed all these amazing disciplines, and it really did put in how art and science links, and that actually there aren't any boundaries, and they help each other. From there, I was very lucky. While studying, I developed a machine which basically turns Coke cans and aluminium cans into a fabric, which is like Lycra. And so when you stretch it, it sort of pulls back again. And I developed this machine which could use solar panel power. And you basically put the can in and it stitches it into an elastic fabric. And it was one of the first elastic metals to be discovered. And from that, I was rather stupidly down in Cornwall surfing with my brother. It was the end of university. And Dyson gave me a call and said, hey, do you want a job? so I went along. 11 years later. So what was the great thing about Dyson? Well, I really enjoyed it. It was the act of sort of freedom where you could just come up with an idea, write it in a book. We all have books which were a bit bigger than this. And you could explore. We had all these wonderful machines. So it wasn't really about, here's a project, you must go and do it. Explore your thoughts, invent something. And it doesn't matter how wacky it is. We'd sit around glass tables and eat donuts and just come up with the most fantastic ideas. And then once we got good ideas, and it'd be sort of 1 out of 20, we learned how to make them into products. We learned how to make them better. And some of the examples I've got here as a prototype, which I'll pass around in a bit. But it starts from something which is 3D printed and then turns into a real product. And really, I spent a lot of time with James and his team, and I learned a lot from there about how you get an idea, how you get it into paper, and then how you market it and how you sell it, and how you beat the competition. We were always told that mistakes are good, and that success really you don't learn a lot from it. Although it's great to have that feeling of success when you go and get a product and it does really well, it's the hurdles that you overcome to get there, and it's learning what you've done to make those mistakes to turn them into a success. Doing it abroad, China. So I was very lucky. I got sent over to China to go and help set up operations there, and that was a real learning experience because we didn't have anything. There was only 3 of us. I couldn't speak the language. Regrettably, I still can't. But it was a real sort of eye-opener. They were huge factories with 10,000 people working in them, and we had to make it work so that we could design products over there, make them, and market them. And it's learning about all the culture and all that sort of stuff, besides just training the teams up as well. But a fantastic experience. So in a nutshell, that really brought everything together for me. And sort of towards the end of my time at Dyson, I was there for 11 years, it really showed me that actually once you've got those foundations, you can go and do it yourself. And I've always wanted to do my own thing. I've always wanted to develop and design my own products. So I jumped out of Dyson after 11 years. And towards the latter end of my time there, I started to build a robotics lab, which include, does anyone know what this is? 3D printer, yeah, got it. So building those, putting those there, and then building sort of 4-axis CNC machines, laser cutters, and then eventually building my own robots, which is what I do now. And so that started all that sort of chain, and I knew that would help me get back into the things I loved. So I knew that I could go and draw something in a book, I could go and put it into CAD, and then I could send it to a 3D printer. And that evening, you know, I could be sat with my friends having a coffee, and within hours, I'd have the component ready, and I could sit with them and ask them what they thought of it, get that immediate feedback, and then I could go back and resketch. And within the space of a week, you'd have a product which is pretty much ready. Whereas back when we started, a 3D printer at Dyson would have cost about £180,000 and required 2 people to operate it. So, the trusted sketchbook, which I've mentioned, which really is my most valuable tool. I carry it everywhere where I go. Computers and CAD. So yeah, a simple thing, CAD station, all of that sort of stuff, and they talk to the 3D printers. These are the essentials for building the lab. This particularly weird-looking thing on the right-hand side, I better explain it. It's a new art project, and I'll come on to that in a minute. But essentially, it's a new process of building sculptures which are sliced, so they have an optical illusion. So when you see them from one angle, they appear solid, and then when you move to another angle, you can look straight through them. And really, it was using computers, CAD, 3D printing, and then simulating these shapes within a software suite that allowed me to make sure that the sculpture was going to work before actually going ahead and making it. Because the bigger these sculptures get, the more expensive the materials, and it was crucial to make sure that they were going to work before I made them. Laser cutting, you guys all know what that is. So you can get them really cheap now. Wonderful tools to make various different jigs and fittings and all sorts out. And 4-axis CNC, for those of you who don't know what that is, it's like a big drill which is mounted onto the end of a robot, and it goes and carves bits and pieces out, so you're left with a model at the end of it. I've got some stuff over in that bag which you can have a look at in a minute, which is CNC stuff. And then eventually, it was never my plan really, I built this lab and I was doing all the things I love to do. I was designing and building products, essentially for other people, but a bit for myself. I was flying these amazing airplanes, which I'll come on to in a minute, and I was doing my art. So the 3 hobbies that I've always loved since the age of 3 were beginning to become a reality. And this is the sort of thing that it helps sort of make. So this is a project called Glance, and you can probably tell why it's called Glance, because it's a guy and a girl looking at each other. In fact, he's a very good friend of mine. And this is a demonstration of sort of the optical illusion that it has. And essentially, you could go and build this by hand, but you'd never get quite the same effect until you've actually generated it on a computer and checked it. The precision has to be very, very detailed. As you can see, the hairlines here on the female in the subject are very precise in the way it gets that look and that contour. And you'll see in a minute the sort of effect that it does. So it begins to disappear. And the further you walk away from it, the heads actually completely disappear. So the next projects will be more based on having something which is vertical. So when you move around it, it will disappear rather than having to sort of peer up and down. It was the weirdest thing going to a gallery and see lots of people going like this, up and down. You think they're playing some sort of weird game, but they were trying to work out how it worked. And so that's vital. The kit to go and make these things is vital to conceptualize. But again, the trusted book helps sort of get all that bit onto paper first. And then the flying. So I was really lucky. I went on to fly this machine, which is called a Legacy 500, which is the only fly-by-wire aeroplane in its category. And so you can see it's got two little control sticks on either side. It talks to you in a male and a female voice, depending on what it wants to say and how annoyed it is with you. And you can program stuff into it. It'll literally look at the weather, where it's going. It can fly by itself, completely remote. You have to be there, obviously. But it's so safe, even to the point that if both pilots fell unconscious, it would take control of the airplane and descend to the correct level until you get your oxygen back. And here's a little snip of it actually working. So this is actually coming in to Bristol, but not far from here, over the Bristol Channel. So when this pops out of the cloud, you'll see that Millfield is on the left-hand side. But you can see some of the computers here in function. But again, all of this goes back to, you can see the engineering working, but obviously you can see the pictorial aspect here. So the aircraft's now turning, it's banking, and the screens are showing you exactly how it's doing that and what it would look like outside. So the computer's building a rendering of the outside of the machine. And it's always nice when you eventually come through the cloud, which you'll see in a minute, to make sure it all matches up and you're not in the middle of nowhere, which it never does. It's an incredibly reliable machine. What I mean by fly-by-wire, when you move the stick, there are no fixed pulleys or cables to any of the flying surface of the aircraft whatsoever. They go straight to a computer, which you can hear in the background. And that computer then interpolates those messages and uses the flying surfaces to allow the airplane to move with absolutely no feeling to the passengers at all. And back to a sunny day in Bristol. So moving forward, you know, I'd had the flying, done the art, and done various bits and pieces. And what I wanted to look at was, is there something I can actually go and do which is different? All this stuff was good fun, but you know, I wanted to invent something that was going to make a difference. So, you know, what's the problem? What's the solution? What's the future? It pretty much comes down to all of those main three questions, really, when you're trying to invent something which is different. And so I sat around sort of trying to work this out, and I think it was a time when there's lots of stuff on TV with David Attenborough talking about the plastics in the ocean and how bad they are, and the fact that a lot of plastics get shipped abroad, they're baled up and get chucked into rainforests. So I was determined to basically build a machine which could try and tackle this plastic problem. And some of them bits and pieces are in that bag, which if you can distribute, that would be great. And you'll see a material in there which is the very first of its kind. So you'll be some of the first people in the world to have ever seen this. And it's a material called Plasstine. And Plasstine is essentially a block of plastic which contains all plastics ever made. So the trouble with recycling normally is that you can't combine all plastics. There are only certain plastics which go together. And as you can see, I mean, it really is a big problem. Nearly all plastics start life as a fossil fuel. And we know that's running out, and we know it's not good for the environment. Plastics make up 80% of marine debris. 8 million tons enter the ocean a year. So I don't know if you've seen the new aircraft carriers that have been built in the UK. That's the same as making 130 of those and letting them go into the ocean and never finding them again every year. And since 1950, the world has created 6.3 billion tons of plastic waste, 91% of which has never been recycled. So what's the future? It's these wonderful things. So these are industrial lasers, and these can tell you a lot about how a material behaves and what it does. Don't try this at home. They are quite dangerous, but you know, if you do, just don't tell anyone. Essentially, it was about building a machine which could understand various components that go into it to make a true composite. You can see in the sample there on the top, it's got labels and various things in it, and it basically works out a way of ignoring some plastics but recognizing others, and then building what's close enough to a homogeneous substance with the materials it's got as a true composite. So this is part of my den. It actually looks like a bomb's hit it right now. You wouldn't even be able to walk in it. But what we've got here is a machine in the background, which is an old injection molding machine, which was built in the 80s, and that's kind of that's the sort of machine that's responsible for a lot of the plastic waste. But it was brilliant at what it did. It was cheap, it made good products, and you could literally leave it to go and do its thing. The components on the right, again, this is going into more robotics, and then the component in the middle is basically a machine which breaks them down into elements. But to build this, I needed new materials. So I had to look at foils. Foils are very good for conducting electricity and using fields and things. And actually, the new one uses gold foil. So it's, I'm sure the Kardashians would love it. It's very bling, it's very gold, it's very shiny. My other half had a go at me saying, well, you know, why aren't you spending gold on me? And I was like, well, this is more important, but you can have any leftovers. So it's an important material. You don't just use fancy materials because they are gold or titanium or platinum. And going from that, really, I spoke a little bit earlier about 4-axis CNC. Now, this is a CNC which is making a robot. So it's a robot making another robot. And you need robots to make very precise components. But again, the cost of all this technology has come down so much that it becomes affordable and it allows you to make these mistakes. These mistakes that I was talking to you about, which we were allowed to make at Dyson, obviously they have a larger budget. And the liquid metal, so that is basically a lubricant which is in the middle to make sure that the bit that is drilling, or milling, I should say, the aluminium billet doesn't melt itself because it gets to quite a high temperature. So the work environment, yeah, making space. When you've got these sort of projects on, space becomes very difficult, and I get told off about it a lot. I live in a tip much of the time. And you can see here that obviously there's a sandwich, a soldering iron, a switch, a 3D printed component, a load of fishing net material, which is in a bag over there, which can go around as well, and a few plants to make it look nice. I think most of them are dying now because they haven't had water. But again, not a priority. The priority is the space. But using these toolkits, which you can now buy online, I'm sure lots of you have seen it. You can buy various motors and switches and stuff, and they're all very, very cheap. And very quickly, you can build something which could quite possibly be the first of its kind in the world. And so, you know, that's what I want to impart to you, is go and build stuff, go and make stuff. New materials. Well, they're not really new, but you all know what this is. Does anyone know what it's made of? HDPE? Have you heard of that, plastic? So it's something that is readily recycled, but for the first time it was almost like impossible to get it to react with polycarbonate, PVC, polypropylene, ABS, and various plastics like that. But Genesis quite successfully brought all of that together and allowed me to mix widely recyclable plastics with ones that hadn't been recycled before. As a result of that, my house became a tip. So this is probably the sort of thing you go and see when you go and chuck your stuff out when you're doing a spring clean. The only difference here, this is our front garden. But these, quite importantly, are, as you can guess, flower pots, which are not recycled at all. So they basically go into landfill. And there are lots of different reasons for that. But processing these plastics and getting them into chip form and turning them into essentially what this is, allows you to then go and put it into a machine that can create an object like that. And that's been sort of a test ground, really. So that's been going through a variety of tests of tensile strength, elasticity, and various other chemical tests. The fishing net that you see, I mean, this is a simple one. So this is essentially a nylon material or a polypropylene material. That's nylon. And melting that down and turning it into a substance and then shocking it in different ways, you can turn pretty cool objects out of something that would normally go into landfill. Occasionally it's recycled, but it really sort of starts to pave the way for stuff which is floating around the ocean, ghost nets, which you might well have heard of. I always refer to this as chocolate chip. So this is basically a fishing net which also combines wood. So those are particles of oak within inside it. So basically you can take smashed up furniture, you put it into this process, and it can start to combine other materials other than just plastics. So one of the samples going around, I'm not sure where it is, you'll see that there's metal in it, there's plastic in it, there's wood in it, and really the combination starts to build quite a lot, to a point where hopefully when this project gets to a certain size, you'll have something which can accommodate any material. A product. So that's what it made. It was a bowl. It's very simple, but it was it needed to be done in a simple way. And interesting about this material, because the bowl is it was just a soup bowl essentially. It's made entirely out of fishing nets. But when you put it in a microwave and you boil a material in it, the material starts to boil, but the actual object around the side of it, the bowl itself, stays at room temperature, and it's incredibly strong. So you can throw it at concrete, you can drive your car over, and it doesn't break. So then we had the pandemic. So obviously everyone's aware of what the pandemic was and is, and we had to stop everything. So I went back down to my underground then and started to think, well, you know, there's problems. What happened? So my other half was in China, and she said, there's a pandemic that's happening. It's going to come over here to the UK. And I was like, okay, we better do something about it. And I started talking to people in London, my friends who are frontline workers, medical surgeons, doctors, and they said, we're going to run out of PPE. We haven't got PPE. Can you make us any? And I was like, well, yeah, sure. You know, you can use some of these machines. They're sat there doing nothing at the moment, and you know, everyone's in bed. You know, we've got the whole lockdown. You know, let's do something. And so really, it was about building a business that was never really meant to be a business, and it actually turned out to be a non-profit organization, but it started in a basement. And it was racing through these designs of various things to get stuff done. And so I'll quickly go through these points, but the overall effect was what it did in its size and its acceleration and the things that I learned along the way. So this is this machine in action, and it's printing 3D components, which is on one of these samples which is about to come around now. And basically, we went back to square one. I needed materials which were readily available. Does anyone know what this is? Foam. What, sorry? Foam. Foam, correct. And guarantee you, everyone's got one of these in their house. Insulator. Correct. It's an insulator. The reason why we used it was it fits, and you'll see it on one of the samples that's coming round. It's readily available, and a lot of the building trades were shutting down, so they were all going into lockdown, and they had abundance of this material, and it's a key component which would sit on the forehead to separate the face shield. Does everyone know what I mean by face shield, the bit that sits in front, yeah? Not the mask. And so it was 3D printing these components, which I designed, and then basically combining it with bits of that, which you'll see on the sample. And then laser cutting rubber. So this is a nitrile rubber. And essentially, we're just getting sheets and making various straps to different sizes and working out the development of that. We had a problem with this, though. And with these things, you often make mistakes. And when I did the first samples for these, we had a bit of a nightmare. So I did the test on a sheet of rubber, and it seemed to work. And so we ordered the rubber in. But what I didn't realize was the temperature that's being used there is extremely high. I mean, you're looking at near sun temperature. And it reacts with the rubber in the way that it perishes these sides. So when you start to stretch it, it no longer has its elasticity, and it starts to fall apart, which they all did. So we had to go back to the drawing board and refigure a way of trying to get this rubber, bearing in mind that these had to go out to hospitals the next day. It was a bit of a nightmare. It was a long night. But we found a material that was suitable, which is a silicon-based material, of which there are samples in the bag, and I'll come around in a minute. Advancing the design. This is my friend. He thinks he's very funny. And this is him probably after a couple of glasses of wine, trying on the kit and giving me his best advice. It's always good to talk to people, and actually he was very instrumental in helping come up with various ideas to get around the problems. But as we grew, we could no longer do it in a basement. The basement's far too small, and we were getting orders thick and thin from hospitals all up and down the country. And so we realized that there are these manufacturing hubs that surrounded us, which were basically on furlough, and they had all this wonderful machinery, this really expensive kit, but they weren't using it. So we asked them, and essentially, using these fantastic machines, we were able to make sheets like this, which are major components, and they'd literally give us stacks of the material, and that was a key component of actually making the shield. Everyone was so willing to help, but what we didn't realize is that actually getting these people, and as the orders grew, we were beginning to take people back out of furlough, which was great. this is the example of the strap which we changed to, which is FDA. And what help do we need? So we needed more space. So we borrowed a church. So we spoke to a bishop, and he said, yeah, you can use my church. And it was almost like sort of going back in time to sort of wartime. I can't remember the last time this church was used like this, but I'm aware it's very old. And it really felt like that sense of community. And so we built this amazing volunteer program, which ended up having 360 people on the books. And it grew very, very quickly, so much so that we had to start building our own machines. So the straps, which you might see, which are probably coming around in a bit, had to be made on a different machine. The people we were using to make the shields and the straps did not have enough capacity to make both of those components on one machine. So I decided to build this robot, which is called Dorothy. And she's rather sweet, but she's got quite a nasty bite. Anyway, her entire job is basically to take straps of silicon in and punch holes in very, very precise areas. The two pneumatic cylinders that you see going up and down can lift a Range Rover clean off its feet. The trouble is, when you're developing things like this, you want to get it done so you can get it into the field the next day. And I was working rather late, and as I say, it's got a rather nasty bite. And it's always the last-minute check you need to do. And so I was finishing this robot off at about 2 a.m. in the morning, knowing that I had to go and take it into the factory probably about 6, the sports hall at that time. And she bit me, and she literally cut the end of my finger off in one go. Rather stupidly, I programmed it to shut close for 5 seconds, so I had to wait 5 seconds for it to open. Now, going to Casualty when you know you've got to get a robot in the next day and knowing that it's in the middle of a pandemic is not fun. But what was very strange was going to a place that was almost deserted. There was not many people around. And I thought, well, this is going to be great. A surgeon's going to come and see me anytime because they'll literally be having a Kit Kat and a cup of coffee. But no, they've been taken somewhere else to deal with the pandemic. So I had to wait there for a long time, like an idiot, with my finger in the air. And they said, how did you do that? I cut my finger off my own robot that I built at home, making your face shields. But, you know, it's all grown back. It's fine. It's a little bit wonky, but it's there. So it was quite a fantastic experience, and we ended up moving to this sports hall, which was kindly donated to us by King Edward's School. And some of the facts on the side here, we ended up making 80,000 face shields, and at one point we were making, we overtook the Royal Mint in production of face shields, which started from a basement. And we were literally, at one point, when we first started, washing the straps in the kitchen sink. So it just shows that if you put your mind to it, like, everything is possible. This little video just sort of summarizes a little bit about the operation and how it was involved. And so you can see it's all like socially distanced, and everyone had to have their temperature taken. We had to have a record whether they had any symptoms. But what was beautiful about it, and I can't overstress that word, was how many people actually felt they were coming together to do something good. There are many lonely people in the world, and quite a lot of these people were isolated at home already, forget a pandemic, and then they were being told they had to stay at home and they couldn't see anyone. But with this opportunity, they could come and get involved in a safe way, and many of them have made friends for life. And so it was really sort of the emotional effect that it had on people, not just this experience of making a necessity for the frontline workers. So where do I go from that? So we kind of wrapped up Foldall, is the name of the company, and essentially it did its job. It filled that gap for when the NHS most needed face shields. And then the government eventually got their stuff together and managed to ship stuff out that was good, and it worked for them. And so our job was pretty much done. And as a non-profit, you know, we hope that at the end of it we'll have a little bit of money for charity, and we want to do a volunteers book, which really sort of highlights this emotional thing that happened. So where are we going now? Well, there was, and there still is, a necessity to make PPE and other life-saving equipment, but it has its environmental costs. As I'm sure you're aware, the economic slowdown has dropped the demand in oil, which is the oil which turns into petrol and goes into lorries and aeroplanes and all sorts. But this, in turn, has cut the price of what's called virgin plastic, which is new plastic. And the trouble with that is recycled plastic is no longer comparable. It's too expensive. China, who imported nearly half of all secondary use plastics, has stopped the import of that in 2018. So we're left in a difficult world where plastics are ever more important, but to buy original virgin plastic that's never been used before is becoming increasingly available because the petrochemicals want us to buy it. And China this year will make 100 billion face masks, and they all will end up in landfill. So what did we do? Well, we went and made the world's first 100% recyclable face shield. And essentially, that is, it was here somewhere. Essentially, that is it's here. It's this, which is a sheet of PET. And you can see it assembled here. And very kindly, Domino's are trialing this for us because they're aware of the need to have a social image, an environmental image. And this can literally be recycled in one go, and it will kill the virus, it will kill anything on it. So this does not touch the land, it does not go into landfill. And that's really sort of the next steps with doing all of this stuff. And it very simply clips onto the cap, as you can see. It has sort of two lozenges, which are like that, and it can be fitted onto any cap. And so we're trialing it with mainly sort of fast food outlets and various other outlets that use this cap. So that's where we're at with that. I'll quickly move on to the next bit, but this kind of wraps up my little speech really for this bit. And I guess what I want to say to all of you is, whatever subject you're studying and whatever you want to do, don't feel necessarily that because you're good at something, that's going to dictate the whole rest of your life and that's the way you want to go. If you're interested in art, art helps engineering. If you're interested in engineering, engineering helps art. And all these skills are transferable. And as long as you're creative with what you do and you're confident and don't worry about making mistakes, you'll realize how important these things are. Make mistakes, they're the most important thing. The other thing is just to go on to this. So have any of you guys heard of this? Together Bands? Yeah? So this is all about building the UN17 Goals, which are the things which they're really putting together to try and change the world in which we live for the better. I've been working with Cameron Saul, which you probably know, to basically try and give this message out and tell people what it's about. So I'm a global ambassador for goal number 9, which is this one, which is the orange, which is industry, innovation, and infrastructure. And this is right quite close to my heart, which is about building machines that recycle plastics. It's about making sure that PPE doesn't go into the ground. It's about not having to use petrochemicals anymore. It's about electric scooters, electric bikes, electric cars, electric airplanes one day, who knows. Anyway, that's what I'd like to impart to you today, and that kind of summarizes my speech. Thank you all very much for having me. If you've got any questions, please fire away. If you want to send me a message or you've got an idea or whatever it is, it's all there. And I really thank you very much for your time.